Hey everyone, welcome back to Tech with Diwana, and this is day 6 of our Kubernetes Zero to Hero series. And today we are entering one of the most powerful chapter of Kubernetes, that is a workload. But before we start, let me hit you with some real-time interview question. So question number 1 is, what is a Kubernetes workload? And question number 2 is, what is a difference between pod, replica set and deployment? And question number 3 is, why are the deployments called a stateless workload? And question number 4 is, can you explain the pod lifecycle phases in a real time? If you cannot answer this question with confidence, you are one escape ad. Away from escaping your next DevOps interview, stay with me till the end because I will not just tell the answer, I will show you a live them our inside a Kubernetes cluster. So let's start building from the scratch. In Kubernetes, workload means anything that runs your application. It is a generic term for the object that manage and run the containers like a pod, replica set, deployment, daemon set, a stateful set, or job. In an interview, they will often ask of which Kubernetes resources to define a workload. And the answer is a very simple. Any object that run a containers directly or indirectly. And today, we will focus on the three most common stateless workload, that is a pod, replica set and deployment. Let's quickly set up our local Kubernetes cluster using a kind, and it is a lightweight and run inside the Docker, the best for the practices. So let's set up and run the command step by step. So see, this is my VS Code as screen, right? So, and I have already mentioned all the steps in our GitHub repo in the day 6. So you can find the GitHub repo, and I will mention that repo in the video description. So just let me show you once again, just like how repo looks like. So see, here is our repo and how you can set up. Step one, so set up a kind cluster. So you need to just create a config file, and inside the file, this is the cluster information, and the role is a one control plane, right? So let me just copy this command, and also you can type. This is not a big command. So let me back to our VS console, VS code, right? So let me create cluster, and name of the cluster is like a TWS cluster, and I have already created the config over here and hit the enter. So it will take less than 1 minute to create a kind cluster. You can see over the screen. So it is in progress. It will take less than 1 minute. Once our cluster is ready, then we will move forward, right? So let's wait until it created our local cluster. So let's wait, and then we will move on next. So see, almost this is done. So let me check. So see there, all the steps are done, and it is a have a nice day. Keep setting the cluster info to cluster info. So let me check. Command is keep scale get node. See, our control plane is ready, right? Here kubectl tl get cluster info. So see, cluster info, we will check kubectl cluster info, scale clusters info, right? This is a command. Still I am in typo. Cluster info. See, so see our control plane is ready. So see our control plane node is ready, and this is perfect for today, and cluster will use for today our workloads. So let's move on forward. So let's create a namespace, and namespace are like a folder that isolate all resources. So So let me create here the namespace, and I will keep the namespace is a demo. L ctl get namespace, yeah, ns ns name is demo, right? Cube cube l get and s and then the demo, right? It is now kubectl get math. Here is our demo, right? And this is a default is cube public cube system. This is a default. So I have created a namespace. So what is a pod? Pod is a smallest deployable unit in a Kubernetes, right? So it is a logical wrapper of one or more containers that share a same network and storage. I know the sound is a little bit technical, but let me simplify it with a real analogy. So think a pod is just like a small house, and inside you can have a more than one room, right? So all the rooms share the same resources, just like a Wi-Fi network. So you can think just like a network is a namespaces, and the water tank just like a storage volume. So it doesn't schedule the container directly. It's a schedule of pods, and that runs inside a containers, right? So let's come on to the next point, that is a pod phases or stages. So first is the pending. That means your container is scheduled or image pooling in progress, right? So second is the running. That means your container is started successfully, right? And third is just like you can think succeeded, right? Means completed successfully for the jobs. And the fourth is a failed. That means your container is crashed or exited, right? So next is unknown. That means your node is unreachable, right? And also the start policy would be in a pod like always, never, on, failure. You can define in a in a deployment manifest. I will show you today how to write a deployment manifest, pod, everything, right? So inside interview you can say that pod is ephemeral, right? Pod is ephemeral. If it is dies, Kubernetes can recreate it, but its internal data is lost unless storage is in place, just like a persistence volume, right? So that's why you can say pod is a stateless workload. So let's create our first pod, right? So let me go on it. Here this is first. So before creating a pod, I will let you know how to just like create a YAML of the pod. First of all, I will let you how to create a YAML of the any pod, or just like a deployment or a replica set. So first I will generate the YAML. I will show you how you can generate the YAML, and further we can apply, and that pod will get a create. Then we will export that pod and we'll take our local system in a browser. So see, so I am creating a pod kubectl run w pod and match x nx latest. You can take anyone nx image and that port I am posing 80, right? minus n, namespace is demo, which I have already created, right? Minus start equal to never, right? That's I will here minus minus, like try run, try run, run, find, try run just and try run is just creating a YAML, and if it will not execute the YAML, we will execute it later. First of all, I will let you know how you can create a YAML, right? So see, minus o YAML here, pod dot just enter, get a pod dot YAML. So see here, that's fine. So see how you can write a pod manifest API version v1 kind pod, that is a metadata. Levels is like a that is a label, run a twd, msg pod, namespace is demo, spec container is just a image test pod. See how you can create a YAML of any pod, right? So use a dry run. Dry run is just as the your pod.yaml, and it will not execute. So let me apply it and create a pod, right? So you can see here, you can check just like a kubectl, kubectl get pod, and no, it will never show. See, no resource found in the demo namespace because it is not applied, just created a YAML. So create l by f and pod.yaml, hit enter. Pod is here, drag it up, that get id kubectl get pod in, right? And my namespace is demo l pod minus n. Oh, see, our pod is not created, it is in a container creating us. So let's wait again, just creating l pod and sn as the okay. See, our pod is now ready. Kubectl try pod, pod name is twd pod, right? And for namespace is demo, right? So you can see the everything pod, you can see the describe. So yeah, pod name, that is demo, namespace, all the things you can check from here. So I am exposing this port, I am providing this port on the AT check in the browser. L port, L port, forward pod and oh, the pod is wd pod e at 30 30 let's see. So let's correct the commands. Keep port forward. Just see. Right now it is forwarding to 80, and let me show you in our browser Firefox, right? And also I have mentioned all the steps in GitHub repo, and I will mention this in the video description. So you can find the each and every command from there. So see here, click on the localhost colon 80, and here see your nginx is exposed in a port in a container. So see how you can create a pod and expose it, provided the port to the AD port, and it is so. What is a replica set? Replica set ensure that a fixed number of pods are always running. If one pod dies, then replica set recreate it automatically. And interview tips: a replica set alone doesn't handle the updates. It just keep a replicas alive. The rolling update, rollback. It is the deployment job. Now let's create a deployment. And how we can create a deployment? First of all, we will create a YAML of the deployment, and further we will apply the deployment, right? So see, uh, also I have done the same steps for a pod. Just here change the name of the pod to deployment, and then also mention here the charge is called. That's only a difference. So let's hit a command output, right? So I have just right here the keep setting the create deployment, and name of the deployment is web. Image is just an Nginx latest. Replica is equal or minus n. This is for a namespace, and write down for a just like a create a deployment YAML. So see, if it will not execute, it will just create a deployment.yaml here. So see how you can write a deployment manifest, right? So API version v1, deployment is defined deployment metadata labels namespace spec in replicas selector and metadata. So you don't need to remember the deployment manifest. You can run a dry run to create a manifest of any like object. So I have done the same for a pod, and second times I am doing for a deployment. So see here how to create a deployment manifest without any remember the anything, right? So let's apply the deployment, dragging it up, right? So uh, scale scale I scale I F and ML. Our deployment is created. Scale get deployment and get, or you can write a deploy. A name of the deploy is just a wave and uh, type D, not D demo. See your deployment is ready and showing here 3 by 3 is up to date and can over. Means that your deployment is created and replica is obtained, right? So see, also you can check replica set scale get get rs, write a short form, get rs, then right. See, so see here wave. This is the name of rs and desired is 3 and current is. So you can easily check replica set also mentioning our manifest replica is equal to 3. You can see the desired state is current is that our replica early. So let's roll out the deployment, right? kubectl roll out a status deployment minus n. When run this command to easily roll out the deployment is out successfully, right? So right now we are just creating a replica is 5 and see how you can increase the replicas, decrease the replicas as per your requirement, right? So command is very simple. So you can is the replicas kubectl like scale deploy and replicas is equal to 5 minus n demo. So it will be create a replicas of 3 5 and you can see here deployment is a scale. Okay, kubectl get deploy n demo. So it should be 5 5. Just I have measured the replicas. 3 is running out of 5. 5 is up to date and 3 available. It is still in progress. So you can enter here until it is completed. So see, wave 5 by 5 is running right now and 5 is available. How we can tell the replicas? How you can tell the like applications, type like something like that. So this is our deployment part. You can easily hands on this demo. Deployment sits at the top of the hierarchy. It creates and manages a replica set, which in turn to manage our pods. Inside the interview, deployment handles a rolling update, deployments allow a rollback, and deployment ensure a desired state. In production, you will always use a deployment for a stateless application like Nginx, Node.js, React, and etc. Site deployment, let's understand the relationship, right? So deployment, replica set, pod, and containers. Deployment controls a rollout strategy, and a replica set handles a desired pod counts, and a pod actually runs your app container. Together, they form the foundation of the stateless workload in a Kubernetes. Why stateless and when to use a stateful set? So see, deployment and replica set stateless workload because each pod is replaceable. Data is not stored inside the container file system, right? So for MySQL, MongoDB, Redis, or data persistent is matter. So a stateful set we use a persistent volume. So inside the interview, the question is that what is the difference between a deployment and a stateful set? So answer is a very simple. Deployment manage a stateless application, whereas the stateful set manage the application but where neither identity and a data persistent, right? So this is a simple answer. So this is our day 6. If you find this video is helpful for you, so please like, share and subscribe to Tech with Diwana. Let's see you in our next video, that is our that 7. Till then, bye bye, take care.